Okay, this is section 9.3 in your textbook on linear relations. It's basically what we've been doing, except now what we're doing is we're applying context to our linear equation. So the first question on our sheet says a long distance telephone plan can be represented as C equals 6t, where C is the cost in cents and T is the time in minutes. Now this question makes no sense to your generation because not one of you have ever paid for a phone call anywhere, because you pay for a cell phone plan and it's usually unlimited calling wherever you're calling to. So the first question, A, says make a table of values using at least 4 whole numbers for T. So what I'm going to do here is I am going to make this table of values, instead of using X and Y this time, I'm going to use T and C. Now on my table of values, I'm going to define what my variable is, and in brackets, I'm going to say the units. So T represents time in minutes, and C represents cost, and it's in cents, not dollars. So for 1 minute of time, the cost would be 6 cents. For 2 minutes, it'd be 12. For 3, it'd be 18 cents. And for 4 minutes, it would be 24 cents. So our table of values, when we fill in the first 4 whole numbers for A, it would be that. Question B says graph the ordered pairs. So if I graph it, down here, I'm going to put T. I'm going to define this axis as T, and I'm going to define this axis as C. I'm going to put those labels in. I'm going to put 1 minute, 2 minutes, 3 minutes, 4. I'm going to say time in minutes. I'm going to make sure that I define my axes, because it's no longer X and Y. It's now T and C. And I'm defining what those 1, 2, 3, 4 actually mean, which is time in minutes. And up here, I'm going to put cost, and I'm going to put in cents to make sure I know that. And we're going to go up by 6, 12, 18, and 24. And when I plot my first 4 points, 1 and 6, 2 and 12, 3 and 18, 4 and 24, I make a line, which means there's a linear relation. Okay? And because I know there's a linear relation, because I knew it to begin with, there must be an equation, and the equation's already given to me. So C equals 6t is what all the values on that line represent. But for question C, it says if part minutes are rounded up to the nearest whole number, is it reasonable to have points in between? So normally what we said before is this point reasonable on this particular graph? And the answer to this is no, it's not. For the only reason is we are rounding up to the nearest whole minute. So for example, if I talked on the phone for 1 minute and 32 seconds, they are not going to charge me for a part phone call. They're not going to charge me a fraction of 6 seconds. They're not going to charge me 3 cents for that 30-second extra part. They are going to make this into a 2-minute phone call because they're going to round up. So they're going to charge me 12 cents regardless if I spoke for 2 minutes or 1 minute and 32 seconds or 1 minute and 38 seconds or 1 minute and 58 seconds. They are always going to charge me by rounding up. So this point will never occur in this scenario. It will either be a 1-minute charge or a 2-minute charge, but not a 1.5-minute charge. Your next question, 6, is an animal shelter hires you to walk dogs for $5 per dog. That's a good job, even back in the 90s when this textbook was made. The relationship between the money you make and the number of dogs you walk can be expressed as W equals 5D, where this represents the wages, or the money you make, and D represents the number of dogs you walk. Right? Because if we walk 2 dogs, of course, we'd multiply that by 5 to get how much dollars you make. Make a table of values. So here I have to decide which one's going to be my D and which one's going to be my W. I'm going to make this my D because I want 1 dog, 2 dogs, 3 dogs, and 4 dogs. And anytime you can have a 1, 2, 3, 4, that's what you should make for your X column. And your W will be $5, $10, $15, and $20. This, of course, is the number of dogs, and this is the wages represented with dollars. Now, you might ask, well, where did these come from? Where did these numbers come from? And the answer to that question is I quickly did some math and I probably should have shown you where they come because it's important. Because if I take my formula, W equals 5D, and I substitute 2, meaning 2 dogs, then W will equal 5 multiplied by 2, because my D will replace the variable as 2. And when I simplify this, I get 10, which is my W value, which means it goes right where my W value is when D is 2. And when D is 3, it's 15. And when D is 4, it's 20, and so on and so forth. So that's where that table of values came from. Graph the ordered pairs. So if I take my x-axis, I'm going to put 1, 2, 3, 4 here. I'm going to call this one, instead of x, I'm going to call it D, representing dogs. Where are my dogs at? Over here, I'm going to go 5, 10, 15, and 20. And I'm going to call this axis, instead of y, it's going to be called the w-axis. It's going to be wages in dollars. And then my points will be 1, 5, 2, 10, 3, 15, 4, 20. Now for this one, is it reasonable, again, is this a reasonable point on this particular linear relationship? And the answer is no, because you can't walk half a dog. Although somebody said, well, what if the dog walks with his front legs and not with his back legs? That still counts as walking the dog, regardless of how stubborn it is. That's true. Question 7. Evaluate each equation using the given values. So for this one, I'm going to write for A. I'm going to write my equation. And I'm going to substitute my x equals 6 right there into where x is. So it's going to be y equals 5 multiplied by 6 instead of by x. And I'm simply going to solve this to get y equals 27. So when x equals 6, y equals 27, and therefore that would be my ordered pair, x6, y27 in that particular equation. In question B, if I change this to a B, it's a different equation too. So y in question B says y equals x minus 8. And this time x is 5, so I'm going to take my equation, substitute 5 where my x was, and 5 minus 8 is not 3. It is negative 3. So when x is 5, there's my ordered pair, the y value will be negative 3. In C, y equals negative 5x, and here our x equals negative 2. I'm going to delete this. So I'm going to take my equation, y equals negative 5 multiplied by x, or this time by negative 2, and y will equal 10. So therefore my x value is negative 2, my y value is positive 10. And finally, the last one, D. Y equals x, you can't ask for an easier question. If y equals x and y is 25, what's x? Well, it says it right there. When x is 25, y is 25, because x equals y. In your next question, 8's easier than 7 because you have one equation for all of the questions. So for A, you're going to have y equals 7x plus 3, but you're going to have it for all of them. The only difference between these is our values for x in all 4 questions are going to be different. So in the first one, A, I'm going to change my x to 1, and I get y is 10. In my second one, I'm going to make it, don't need to write that yet, B, x is negative 4, so 7 multiplied by negative 4 minus 3 is negative 28 minus 3, which is negative 31, is my y value. In C, x is 0, so 7 multiplied by 0 plus 3 is 0 plus 3, so y will equal 3. And in my last one, y equals 17, or x equals 17. 10 times 7 is 70. 7 times 7 is 49, which means this is 119 minus 3, which means y equals 116. In question 9, make a table of values for each equation where x is going to equal all of these values. So again, just like the last question, this is fairly easy because when I make my table of values, x will be -2, x will be 0, x will be 2, and x will be 4, which means I can take this table of values, I can clone it, I can actually infinite clone it, and for me, because I have the infinite cloner capabilities, I'm going to make all 4 of them here. So once we have our tables of values met, I'm going to write down the appropriate equation for each of these tables. This first one is A is this one, B is this one, C is this one, and D is this one. So for all of them, what we're going to simply do is substitute -2, 0, 2, and 4 into the entire equation, or more specifically, where the x value is. So for the first one, it's going to be 3 times -2 plus 2, which is -6 plus 2, which is -4. That goes there. When x equals 0, it's going to be 3 times 0 plus 2, which is 0 plus 2, which is 2, which goes there. When x is 2, it's going to be 3 times 2 plus 2, which is 6, plus 2, which is 8, which goes here. And finally, when x is 4, it's going to be 3 times 4 plus 2, which is 12 plus 2, which is 14. In the second equation, I'm simply going to substitute again -2 take away 5, which is -7. 0 take away 5, which is -5. 2 take away 5, which is -3. And 4 take away 5, which is -1. Here, -4 multiplied by the first x value, which is -2. So -4 times -2 is 8, which goes here, times 0, which is 0, times -4, which is there, and -16. And finally, the last one, if I substitute -2 for my x, I get 7 take away -2. Of course, when you're subtracting, it's easier to add the opposite to get 9. 7 take away 0 is 0. 7 take away 2 is 5. And 7 take away 4 is, I made a mistake somewhere, 7. 7 take away 0 is not 0, it's 7. So 9, 7, 5, and 3. Question 10, make a table of values for each of the equations. So, for each of them, I'm going to use 1, 2, 3, and 4 for all of them. Okay? So I'm going to take this table, and I'm going to infinite clone it, I'm going to make it 4 times. And for the first one, y equals 2x. If x equals 1, y equals 2. If x equals 2, y equals 4. If x equals 3, y equals 6. And finally 8. In B, y equals 3x minus 1. If x equals 1, y will equal 2. If x equals 2, 5. If x equals 3, 8. And if x equals 4, 11. And by the way, it says give at least 4 integers for x. So the reason why I chose 1, 2, and 3, and 4 is it's the easiest 4 numbers to work with, and when we graph them, it's the easiest one to graph them with as well. In the third one, C, y equals -4x plus 5. So when x equals 1, y will also equal 1. When x equals 2, y will equal -3. When x equals 3, -7. And when x equals 4, you'll get a -11. Okay, so of course, -4 times 4 plus 5 is -16 plus 5, which is -11. Right there. And finally, your last question, y equals 5 minus x. So 5 minus 1, which would be 4. 5 minus 2, which would be 3. 5 minus 3, which would be 2. And 5 minus 4, which would be 1. And once you have those, you're to graph them all. Uh, I'll just graph the hardest one because I think the other ones are pretty easy. I'm going to graph the third one right here. So on our x-axis, for this one, I'm going to need to draw all of my axes because I have y values that are both positive and negative. Okay? So I'm going to make it go up by... Now the range in my y-axis, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I have to go down 11, and I have to go positive 1 on the y. So those are all, that's the positive 1 right here. And that's the negative, right here is the negative 11. So that's all I need in the y-axis. And a 1, 2, 3, and 4 on my x-axis. So when I graph them, x is 1, y is 1 is right there. X is 2, y is negative 3 is right there. X is 3, y is negative 7 is somewhere like around here. And 4, negative 11 is right around there. When I connect the dots, I make a line. Question 11 says in the graph below, it represents part of the linear relation y equals negative x. In fact, it represents 3 points. It says use the equation to calculate the y coordinate when x equals negative 1. Well, an easier way to do that would be to take a line and to simply connect the parts together. And then say when x is 1, negative 1, which is right here, what is y? Well, there it is. There's x equals 1. And using what we call, this is called a grade 9 concept of interpolation, is to go between 2 points that we know. We figured out that when x is negative 1, y is 2. But instead what we can do is we can use this equation, so write it out, and substitute x equals negative 1. So x equals negative 1 gives us this, and when negative 2 times a negative 1 is a positive 2, which is our answer. In question 12, the graph represents part of the linear relation is x equals a third of x. Y equals a third of x. What are the coordinates for each point on the y-axis? So again, if I took my line and connected the dots, there's my linear relation-ish. I guess not so good, but hang on, let me just do that again. Take my line, connect them a little bit better. That's a little bit better, but not great. What are the coordinates for the point that lies on the y-axis? So remember, this is the y-axis right here. That's the y-axis right here. So what is the coordinates for this point right here? The coordinate, of course, is 0, 0. In grade 7, you learned that was called the origin, right? Use the equation to calculate the y-coordinate when x equals negative 3. So again, take my equation, y equals x over 3, and substitute x for negative 3. What would the y value be when x equals negative 3? Well, negative 3 divided by 3 is negative 1. Let's see if that's right. So there is y negative 3. Sorry, x negative 3. There's x negative 3. If I go down here and find this point, what is the corresponding y value? Y is negative 1. Skip that last part. Question 13, graph the ordered pairs in the table. So, make my x-axis. I need to go to 7 on the x. There it is there. So the first one is negative 2, 0. So negative 2 on the x is right here, and 0 on the y. So there's my first one. That's negative 2, 0. 1 on the x and 2 on the y is right here. That's 1x, 2y, or 1, 2. And 4, 4 would be 4 on the x and 4 on the y, which is right here. And the last one, 7 on the x, 6 on the y, somewhere up here. When I connect those dots, it makes a line. It says, is it reasonable to assume there are points between the ones on your graph? So is this a point right here. Is this okay to assume that that's a point? The answer is yes, because we don't know if it's talking about dogs, if it's talking about phone call costs, if it's talking about anything in between. So we assume it is unless we know the context of what the line is representing. Question 20, you're given part of a table. How could you use the pattern to find the missing coordinates? Now, I always like taking the table and reorganizing it like this because I see it better. That's just me. Maybe you like it the other way. So -3, -2, and -1, I don't know the why. But 0, 1, and 2, I do. It's 6, 8, and 10. So how could you find the missing coordinates? Well, the one way you could do it is going down by 2, which means this would be down by 2, and down by 2. That's one way to find those missing values because it's going down as we go up the chart. Another way is to simply take the equation that we know, x and y, put 0, 1, and 2, 6, 8, and 10, and find the equation for this part of our table. This is going up by 2 and up by 1, so it's going to be 2x plus 6 equals y is our equation. And once we know that, we can substitute these three values into my equation to get the corresponding y values. In a bulk food store, rice crackers sell for 80 cents per 100 grams. Copy and complete the table. So, if it's per 100 grams, if you bought 0 grams, it would cost you no money. If you bought 100 grams, it would cost you 80 cents. If you bought 200 grams, it would cost you 160 cents or $1.60. If you bought 300 grams, it would cost you 240 cents or $2.40. If you continue the table, what is the most logical value for the mass of purchase? Of course, 400 would be the next logical value. And what would its cost be? It would be an extra 80 cents, which is $3.20 or 320 cents. I'm graphing the ordered pairs. We're going to put mass here, and we're going to say it's in grams. So we're going to say 100 grams, 200 grams, 300 grams, and 400 grams. And then we're going to say cost in cents. So it would be 80 cents, 160 cents, 240 cents, and 320 cents. There's our graph of our points. And there's our line. And finally, our last question that we're going to do. The graph shows Nigel's monthly earnings. Is this our last question, by the way, on our sheet? It is. If Nigel does not make any sales, what are his monthly earnings? Well, I'm assuming he makes no money, but what we have to do is figure out what is the equation for his salary. So we're going to make a table of values to start. S represents sales in money per thousand. So it's in thousands. And this is going to be our earnings in dollars. So if he has 0 sales, right there, 0 sales, how much money does he earn? Well, he will earn $1,200 just for showing up for work, even though he sold nothing. If he makes $1,000 or $1,000 in sales, he will earn, according to this, in between $1,200 and $1,300 will be $1,250 in sales. I'll just do one more. If he sells $2,000, that's thousands, he will make $1,300. Okay? So it says, Nigel has sales of $4,000 in 1 month. How much does he earn? Well, according to this, for B, he would earn $1,400. And if he sold $1,500, $1,500 is right here. So here's the question. If he sold $1,500, what are his sales? What do you suppose we would use to figure this out? Yeah. Oh, he earns $1,500. Oops, my bad. You're right. So now I have to change it. So $1,500. If I draw this line again, connect those dots, can we read how much he would have to sell to make $1,500? Does everyone agree he would have to sell how much? He would have to sell $6,000 in sales.